So homework 3 we're pretty much good on, except at AO3 would be a little difficult at this moment, but it'll be within reach in 50 minutes from now. So AO3, there you do have to actually modify the front end, the JavaScript and the HTML that's provided, or, well, it depends how you do it, I guess. But you do have to modify the front end, and we haven't talked about that at all. So today we're going to go through that big old JavaScript file that's given for homework 3 and just talk about what that thing is actually doing. So that's the goal for today. So I have my server running, and it's printing out all the WebSocket stuff, which actually I might do that to start, is go through one of these WebSocket frames and finally finish that conversation. I feel like the music cut me off twice when I was trying to get through the end of it. So let's go through a WebSocket frame first. I have the, I don't have it open. So let's navigate to the website, localhost 8000/WebRTC, and not a Google search. I couldn't finish it there, but I got to get rid of that suggestion. And it's going to go to this app. It's going to go to my site, and I can, something very useful, I think I did this in lecture, but something very useful when debugging WebSockets is going to, I have to refresh, is going to the WebSocket HTTP request. If the handshake goes well, you should see this 101 switching protocols with your response here. And then once that handshake occurs, you can go to messages and see all the messages that are being sent to and from the server. So this is a red down arrow. That means this is information that I got from the server. And if I go into my chat, I'll see a message being sent to the server in this specific format that's specified in the homework handout, and you can see in the JavaScript. And then the server is going to turn around and say, hey, got a message. It's a chat message from this user. This is the random username that the server assigned to my connection. And this is what that person said. They said hello, and then that message is rendered on the front end. So let's start looking through the JavaScript. Let's at least look through that part of it. And probably just mostly go line by line through this. But it was so loud I could hear what you're saying down here. So the very first line, this is creating the WebSocket connection. And with WebSocket and WebRTC, the browser does do a lot for you. A lot of these protocols are coded in the browser. So the browser has this new WebSocket, and it knows what to do after that. You give it the URL where you want to connect, and here's where we're specifying /WebSocket. This is whatever the path is that you want it to be. But I specified /WebSocket here. So when the initial request goes out, it's going out to /WebSocket. So this can be, especially for your own projects and everything, whatever you want your WebSocket path to be, you can have it be something different. But I just chose WebSocket. There's nothing special to that path. It's just the one that I wrote here. And then when I coded my server, that's the path that I'm expecting WebSocket upgrade requests on. No magic about that path name at all. I can name this whatever I want, and it's still going to work. I remember talking about this in lecture this semester, but I forget in what context. Maybe it was WebSockets the week before break. Maybe it was just so long ago, 2 weeks ago now, that it must have been in this context. But getting the host from window location host, it definitely was. Window location host, I recommend doing this. I won't go through the whole story again, but get the host dynamically, and we can see that was localhost 8000 in this server. I'm not running it through Docker right now for what it's worth, so I'm running 8000 in the container, and then if I spun up Docker in Docker Compose, it would be 8080 to stay consistent with the course. There's nothing special about 8080, by the way, either. It's just a common dev port, but that's the one we're sticking with in the course, just to make things uniform. So the host, get it dynamically. Then when you go to deploy with a domain name, this host will just automatically change to your domain name instead of localhost 8000 or 8080. When I'm running in the container like this, it's 8000. When I run it outside of the container, it'll automatically change to 8080. I don't have to worry about updating my port in my JavaScript. It just automatically changes to whatever host I'm running this code on, because your code can run on many different hosts. We just saw 8080 and 8000 for this code. And this code actually, just to foreshadow things a little bit, can also run it on port 440. I just said I'm not running it in Docker. I know that, damn it. I'm not running it in Docker, so that part doesn't work. I suppose I could just spin it up, but anyway. HTTPS would have worked there if I spun up Docker. I don't even have the Docker process running. Let's not do that. I do have Zoom running for some reason, though. So that creates the connection that does all the handshake stuff. As long as your server is configured to do the handshake, that's the only line you need to test your handshake part of your code. Then I have this. This is the first part that I would have to change for AO3. I'm creating a WebSocket. I'm creating a variable which is going to contain my WebRTC connection information. I have this hard-coded to just have one connection in the handout code. So this will suffice to get you through application objective 2, when you can assume that each peer only has one connection to one other peer. But when you switch to AO3, you have to change this to be able to support multiple connections. And that'll be a theme throughout today's lecture. Whenever we get to a point where we get code that's hard-coded to one connection, I'll point it out and say, AO3, this is where you'd have to change it to multiple connections. So that's one of the biggest changes that would have to happen. I'm adding an event listener for the enter key. This is just for convenience. So when you're typing in chat, you can just hit enter instead of actually clicking the send button. So minor convenience on that one. The send message method is actually what's being called when you send a message. When you send a message, I'm going to grab whatever message was sent. I'm going to clear out the box. This, I found out the hard way. This is almost necessity for the user experience. If you don't clear out the box, what people do is click send or hit enter, think nothing happened, and then hit it 20 more times, and then that message will show up 20 times in chat. Once I realized that, I'm like, well, yeah, of course, I would do that too, but I didn't catch it in testing. I released the chat app to the whole class, and I got all kinds of spam. So clear it out. I refocus it. Some of this is just UX stuff, but refocus it so you can immediately type a new message, and then fire off that thing over the socket. So I have this socket connection that we stored from the new WebSocket after the handshake, and I'm sending that message in the proper format. So this is where that format from the homework document, from the handout, is enforced. We're creating message type of chat message and then sending the comment over this connection. The server is going to see that a message was sent over this specific connection and attach my username to that message, sanitize all the HTML, and then send it off to everybody, including the sender. This message type, we're using our WebSockets to send 4 different message types: chat messages, WebRTC accepts, WebRTC offers, and WebRTC candidates. So we have 4 different message types flying over these WebSockets, and we need a way to tell what message is what type. Like when your server gets a WebSocket frame, what is it? Is it a chat message or one of the 3 WebRTC messages, and which one? And we need to know. So this is a solution, not the solution, but this is the one that I coded for the homework, is having a message type key in the JSON itself to specify as a string what type this message is. There are other solutions to this. This is one of the things that Socket.io does for you, which we briefly mentioned in lecture one time. Somebody asked about it. Socket.io is pretty much like the WebSocket library that you'll use in the real world, including on your project in this course. I expect to see Socket.io all over the place. It's like the de facto WebSocket library. It uses WebSockets, of course, but it adds a couple quality of life features on top of that. And one of those features is adding a message type in a cleaner way so you don't have to jam your message type inside a JSON like this or any other way you have to figure it out. It'll actually maintain your message types, and then you can handle each message type in a different way with nice convenient syntax, nice and clean and easy to work with. We don't have that since we're using raw WebSockets, so we have to add the message type somehow to be able to handle these different messages of different types in different ways. So that's the way we do it in this class, just message type and then the actual contents of that message. So when we send a chat message, we send it over the WebSocket. The server will broadcast that to everybody. And we're going to get this add message method called, where do I set up my add message? Get chat history. Here we go. WebSocket. So whenever I receive a WebSocket message, a message over the WebSocket, I'm going to run this function, which is going to parse the message. It's always going to be JSON. And I'm going to grab the message type so I can know what that message type is and use the old switch case syntax to decide what type this is. Is this a chat message? If it is, we're going to call that add message function that I just skipped over. We'll go back to. If it's an offer, an answer, a candidate, we're going to do different things based on those. And if it's none of those four, we're just going to print a quick error message and say, something went wrong. You got to fix something. Most likely in this case, like a lowercase m in chat message or something like that that you'd have to fix. So if it's a chat message, let's focus on chat for now. We're going to add that message to the screen, which doesn't do anything too fancy. We're going to get that, it doesn't do anything fancy at all. It's going to get the chat div and then append, importantly appending here instead of setting it equal to, the HTML of adding that message to the chat. When we do this on our server, when we're looking at our WebSockets, that's when we see that in action. We send the message, we get this sent over the WebSocket frame, or over the WebSocket connection, and then we expect the server to be sending this back. And we see we got username user31 in this case, for what it's worth, for a random user. Get these things bigger. And so we got this message. Let's look at this on the server side. Something I kept meaning to get to. Let's do it at the beginning of the lecture so I don't get cut off this time. Let's take a look at the output here. We know, and in fact it's parsed, everything's parsed properly here. We get this message type, chat message, comment hi on the other side. So let's take a look at the bits of this WebSocket frame and make some sense of these bits. So we have the fin bit of 1, meaning this is the only frame for this message, which we would expect for a short message like this. Marauder prophecy, looking for never wasting an opportunity. The 3 reserve bits, they're always going to be 0 for our purposes. And then the op code 0001, meaning this is text information. The masking bit, meaning we do have a mask, a 4-byte mask. Then the 7-bit payload length. And this time I will actually go into the converter. Binary, you know what, we can do the math. So 1, 2, 4 plus 8 is 12, 16, 32, so 44 should be the length here if we read the binary. And we can see that my code did parse out 44 from that. So 44 from the payload length, which is importantly not 126 or 127. So we know that this is the entire payload length. We have a payload of 44 bytes. Since the masking bit is 1, we know that this is going to be our masking key. So the payload, and there should be exactly 44 bytes of payload here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 4 is 40 plus 1, 2, 3, 4. We got exactly 44 bytes of payload matching our payload length. and then that's XORed with these 4 bytes. So if we XOR this is going to be, I'm only going to do this for, 2 bytes probably, just to show the pattern. But we're going to XOR these 2 bytes. We could do it for a few, I guess. I just need a place to type. Let me not open notes. Never mind. I'm going to skip my place to type. I'll type it up here, I guess. So let's pull up our ASCII chart. We expect this to be ASCII values. There's a good one. This one's okay, I guess. No, I need binary. Oh, man. There we go. So we're going to get 0, 1, 1, 1, 1, 0, 1, 1. Well, that's a lot of ones. So 0, 1, is this 8 bits? It's 8 bits, so they're all going to have a leading 0. So 0, 1, 1, 1, 1, 0, 1, 1. And we get our open brace. I don't know if y'all can see that. So we match the binary. We get this binary after XORing the first byte of the masking key with the first byte of the payload. And we do get our open brace, which is the first character that we expect in our payload in this case. Then we would do the same thing, the second byte and the second byte, the third byte and the third byte, the fourth byte and the fourth byte. And then when we get to the 5th byte of the payload, we wrap back to the first byte of the masking key. So when we get to this byte, this is the second one I'll do, just to show the whole pattern, is XORing this. You know what, let's skip to this one, just so we get a different byte. The 6th byte of payload will go again to the 2nd byte of the masking key, or the 5th index to the 1st index. So each time, what I recommend is going through the payload, the bytes of the payload, modding the index of that byte of the payload by 4, and then that's going to tell you the index of the masking key that you have to XOR it with. Instead of trying to do these 4 bytes at a time, I recommend doing it 1 byte at a time. Then you don't have index out of bounds concerns. So this byte will be XORed with this byte, so it's 0, 1, 1, 1, 0, 0, 1, 1. So 0, 1, 1, 1, 3 ones, 3 ones, then a 0, 2 zeros and 2 ones. So 2 zeros, 2 ones. We get this character right here, which is an S. So I hope the 6th character in my message is S. 1, 2, 3, 4, 5, 6. There's my S right there. So we decoded that, we demasked it using an XOR operation, and we're able to decode this stack frame, this WebSocket frame to be able to get our message. And of course, we go through every byte, but we're not going to do that. We're going to write code to do that for us. But just to verify what's going on, to show you what's going on, that's how we get the data out of this. And then when we want to, you have to test with the 126 and 127 modes for the payload length. And I mentioned this very briefly at the end of last lecture. I like to do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You're free to do whatever you want, but I like this one. And I'm going to do Control-V, Control-C, Control-V 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's send it just for fun. We got a payload length of 142 because we do have some overhead with the JSON, but we have something that's over 100. I'll grab it right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to copy it again. So I should have 1,000 on my clipboard. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should be 10,000, which I'm overshooting my goal here. That should be enough for our next mode. So if we look at the next message, it should be the 100 bytes, 142. And this next message is going to be our big one. So we get 126 for our payload length, which means that our actual payload length is the next 2 bytes. So these 2 bytes here, and this one I'll use a converter for. I probably should have just pulled that calculator up. Binary to decimal. 1951, is that what we expected? Let's go to our console to test that. 1951. Did I miscount there? I feel like I miscounted. The number doesn't make sense. But 1951, so we get that value that we decoded that from our payload length. And then the next 4 bytes after those 2 bytes of payload length would be the masking key, and the rest would be the same structure. We have our big value here. I don't know what I messed up here. Let me start over for the next one, I guess. So we want to make sure the next one's over 65,000 characters. So let me catch up on chat. What did the message start with, server sending one? What did the message start with, server sending? When the server sends the stack frame, it'll be the same format, except the masking bit will be, I'm not printing them out on my server, so I can't really show you. Maybe I should be. But the masking bit will be 0, and the 4 masking bytes won't exist at all. So I'll kind of simulate what that looks like. Is this bit would be 0. These 4 bytes wouldn't exist at all, and these 44 bytes would come right after the payload length, and they would be unmasked. They would just be the raw ASCII values in this case. Be unmasked. There would be no XOR when you're sending a frame from the server. Let's do this again. Hopefully I can count right this time. So 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Grab this on my clipboard. This should be 100,000. Okay, I counted right that time. 100,000, and this should show our next payload length if I don't overflow my console, which I think I did. Whoa. Yeah, I overflowed the console. But this would be the 8-byte payload length. We would see all 1s for the 7-bit payload length, and then the next 8 bytes would be the actual payload length. And unfortunately, I overflowed my buffer for my console on that. But we do verify. We sent 100,000. We got 100,000 back. And we get extremely long message that I won't be able to scroll for. But that would be our other payload. That would be our other payload length mode. That's actually convenient because I didn't want those anymore. Something that confuses me is, can we write this to an array, or how do we create the frame to the socket connection in binary? The frame to the socket connection in binary. So when you call receive, that returns an array. It's an array of bytes. Might be the piece that you're missing there. So it's already an array. How can we write this to an array? Or do we create the frame? So for example, when you're sending the message, you have this text, and you do dot encode. That converts it to an array of bytes. That's exactly what we've been doing all semester, is creating an array of bytes. Creating the header bytes is a little trickier. You do, but you can convert your integers to bytes and then append them to your array. But like I said, it does get a little bit tougher there. Not too bad. You just got to know the methods to call. I think I showed some of them in lecture. I forget which ones I showed. Is it safe to go here? No. I can't open that file. Not today. I'm not ready. I'm not prepared for that. If you make sure the type stays as bytes, then you can just use the bytes already. Bytes are 8-bit integer values. So if you just work with bytes but use them as integers, that's the easiest way to do it. But at some point, like you'll have a payload length that is either 2 or 8 bytes, and you have to convert that integer to your byte array. That part is either tricky. There's definitely ways you can do it. You have the programming skills to be able to do that. Or you find the right methods, which I did show in class at one point, I believe before break, that you can just call those methods. Okay, so that's WebSockets. Any other questions about WebSockets? I'm going to move full on into all this WebSocket JavaScript. Hopefully we have time to get through it. I think we will. I guess one more WebSocket-ish thing, the get chat history. It's just an AJAX call that's going to call add message on each message that responds with. So you're returning an array of those messages where each message is a JSON object. We're going to parse that JSON that you send back from your server, iterate through each message, and then call the same add message method function. I'm used to Java in 1.16 now, so I call everything a method. Function in this case, to add that to the chat. Okay, let's skip that stuff for now and show how sending these, how starting a WebRTC connection happens. Then we'll see when we get messages from the server, how we handle those. We'll go back up to those. So first, the start video method, which I'm not calling anymore. You can see it's, oh, wait. No, this is never mind. I'm looking at the handout code. I was thinking for a moment that I was looking at my modified code. This is grayed out. It shouldn't be, though. The front end calls this somewhere. Oh, because I removed the button in my front end. Oh. I mean, you get the idea, but I feel like I'm blind right now. But this is what's called when you click the Start Video button on the front end. Start Video just has an on action, on click, I forget what it's called on HTML buttons. But it calls this function when that button's clicked. And this is going to set up your video feed. So this is going to have some parameters. One, the constraints. If you want to test without audio, you don't want to have that awkward echo thing before you mute your tabs like I did in my lecture example. You can change this audio to false and just get rid of that. Or if you just want to do an audio call, if you ever want to change those, again, you get the idea. I don't know why I'm dwelling on that one. And then we start to get to the real part. Navigator.mediadevices.getUserMedia of these constraints that we gave. Then, which is a promise, it's going to call this function after we get the response from this method, this function call. It's going to call this function that we give it. This is the newer, cooler, which is not so new anymore, way to handle callbacks, like how we've seen callbacks even in our AJAX calls. We have a callback function. Here, it's just a more streamlined way to do that with promises instead of callbacks, which is any code I write these days, I ended up using promises because it's the better way to do it these days. But they didn't always exist, so we couldn't always use them. But this will call your callback, now I'm saying callback anyway, with a stream that it gets from your browser. So once this line of code is executed, that's when your browser says, hey, this tab would like to use your camera and your microphone. Is that cool with you? That's what this is going to do, is actually access your hardware. The browser is going to talk to your hardware and get information from it and turn on your camera and turn on your mic. So you'll get your green light. I got my green light on my camera right now because the tab is accessing my video. That's what this line is doing. And then you can do whatever you want with that data that you're getting from your camera and mic. Here I'm accessing a div of my video. If I can get the right one here. A video of my video. The HTML video tag is pretty powerful. It does a lot of this stuff for us. But I have it ID of my video, autoplay and muted for what it's worth. And then I'm going to set the source of that element to that stream. And that's it. Like, the code isn't complex here. I mean, unless it's the first time you're seeing promises, then that's a little trippy. But this is all you need to be able to display your own video in your browser. That's it. That's all you need. If you want to write an app that's basically like a mirror, that's it. That's all you need to do, this part. The rest of this is all WebRTC stuff, creating the connection and doing the peer-to-peer thing. So first, our ICE configurations. And this is where we talked last time. We need to change this to URLs. I was looking at examples. I was looking into that, and it wasn't even taking an array. It wasn't even an array. I would expect this to be the case, unless the document I was looking at was itself wrong. But it does want that to be called URLs. That's why Firefox is given that deprecated warning. Here's our stun server that we're going to use for Google so we can learn our public IP and port. And then we're going to create a new RTC peer connection with those configurations. And the configurations, that's where you specify like your turn server as well, and any other configurations you want. All we need is the stun server. So we're going to create a new connection and set it equal to our kind of globalish variable for our RTC connections. This is one of the spots where if you're doing AO3, you got to do something else here. You do need to create a new RTC peer connection object for each peer. So there are a few challenges here. One, how do you know how many of those to create? And two, how do you manage those to make sure that you use the right connection for each individual peer that you have that you're connected to? I'm going to add to that connection my own stream. So each time you create one of these connections, you'll add your stream to it. So that connection knows what data you want to send over the stream. And whenever a new stream is added, we have to decide what to do with that stream. Here we have another video element. That's other video, plural in my example, but it'll be another video element. I'm going to grab that and set the source of that video to whatever I get from the stream. This is another change. As you just saw in my code, I don't have this video tag in my code right now because you have to have multiple video elements, one for each connection that you have connected to. Now, my intent for this, what I did in my solution at least, is to use JavaScript to create those elements. You can use JavaScript to create new HTML elements and then add them to the DOM. But I never really talked about that in lecture, so that's one reason why the testing procedure says we're going to open 4 tabs. You're going to have 4 peers all connecting, so each peer is going to have 3 connections to manage. So no harm, you won't. What am I trying to say? I won't care if you hard code 4 video elements in your HTML and name them like video 1, video 2, video 3, or whatever you want to name them, and then use one of those for each of your peer connections. If you hard code things to work only up to 4, I'll be not thrilled, but I'll be okay with it for what we're doing in this course. You don't have to handle an arbitrary number of connections, though, I mean, you should. If you're willing to take on the challenge of AO3, why don't you can actually do the whole thing. But if you don't, if you hard code it to 4, I'll be okay with that in terms of grading. It'll hurt my soul, but I'll be okay with grading on the grading side of it. So we want to add that stream to the other video or one of the other video elements, or add a new element dynamically to the HTML. And then we have this onIceCandidate variable, which we're going to set equal to a function. This function is going to be called whenever an ICE candidate is ready to be used. There was a slight change in the code for when the homework was very first released. I updated it now. Hopefully that update happened. Hopefully it's live. I don't remember if I double-checked it. To add this if data.candidate, then send the candidate to the server, is where our server is finally coming in. Without this condition, sometimes, and I don't know why, we would get ICE candidates that were ready, that the library says, hey, I got an ICE candidate for you, and the candidate would be null. And then it would send null to the server, which was just weird. So I'm checking if it's null. If it's not null, or if it's null, don't do anything. If it's not null, do something. So we're going to send that over the socket, getting the actual candidate itself. This contains all the information of the candidate, and we don't have to parse this information. When you're doing the homework, you don't have to actually pry into the WebRTC stuff and see what it has in it, what it's doing. So the candidate itself, don't worry about it. Our job is to route this stuff to the right peer. We're going to get information where it's supposed to be. We're not going to worry too much about what that information is. But this is the ICE candidates, so going to the stun server or broadcasting localhost stuff in our testing cases, that's going to be contained in this candidate. The port, the IP address, the UFrag, that we're going to use UDP, all that stuff's inside this message right here. Our job is to route it, so we're going to send it to the server with the message type of WebRTC candidate, and the server is going to know that that's from us because it came across on our WebSocket connection. And if you're doing AO2, you just route it to the other connection, you send it to the other peer. If you're doing AO3, you're going to want to modify something here to make sure the server knows where to send this candidate. Because each connection you create is going to have different candidates. You're going to use different ports for each peer you're connecting to. So when you get a candidate for one specific WebRTC connection object, if that one has an ICE candidate ready and calls your function, says, here's an ICE candidate, that's specifically for that peer. So your server has to make sure that candidate goes to the right peer, or else things aren't going to work out the way you want them. You're not going to get the connections. So this candidate is for this connection, which is set aside for one specific peer, and we wanted to make sure that it gets to that peer. So before that can even happen, your client needs to know who the peers are, who's it even connecting to, which is, I might as well just spoil this one, right? That you'll want to have another endpoint. What I recommend, you can solve it however you want, but having another endpoint where you can ping the server with an AJAX call and say, who are all the people? Give me a list of all the users who are connected to you. And then you can use those usernames that the server generated as your unique IDs, identifiers. And then you can say, hey, server, I created this connection for this particular user. Can you send this candidate to that user? Then your router can read that information and send it to the appropriate other user by their username. You also want to know, each user also wants to know its own username. So that was just kind of spoiled if you were watching when I was opening the messages. My server's sending a WebSocket message and saying, this is who you are. So they at least have their own ID as well, which can be useful to know who you are. So that's when an ICE candidate is ready. It's going to call this code and send that to the server. When we first start up the code, we have this welcome function, which we had this for a long time. It had this is from JavaScript, it had that forever. But now it's added to call chat history. And also, if you don't want to click start video every time, if it's becoming a pain in your debug process to click the button every time, you can uncomment this line and just have the video automatically start. You saw whenever I opened my page, I didn't have a start video button. I just have the video start automatically. It just saves me a click each time I'm testing, especially when I'm opening multiple tabs. I don't want to go through each one, click start video. So, uncomment that if you want to save a few seconds. It doesn't save a ton of time. And then when I want to connect, this is the function that's called when you click start video chat, video call. I forgot what I put on the button. But this is the function that's called when that button is pressed. And it's going to create an offer with create offer method. Very good name. Again, I only have one connection here. This is where when you want to click join the meeting, you want to ask the server, hey, who are all the people? And then go through all those people and go create a connection for each one of them, and then create an offer from each connection. You can't use the same connection. Like one connection is just for one peer. You have to create multiple connections, one for each peer that you're going to connect to, again for AO3. One for each peer you're going to connect to, and then that connection is just for that peer. So any offer that you create, any candidate that you create through that connection, or that's created through that connection, and any accept that you receive has to be consistent, has to stay for that connection. And the other ones likewise. Each connection has to have its own offer, its own accept, its own candidates, and everything has to be routed to the right connection. So making sure all that's routed right for AO3 is important. Here we're going to create an offer, and same thing as the candidate. The offer, we don't really care what's in it. We don't have to crack it open. We're just going to send it to the server as a message type offer. And your server is going to handle what to do with that offer. And then we're also going to set the local description of the connection to that offer for what it's worth. If you don't have that line, things will break. And we're on to the server. So the server is going to route things to us in the appropriate way. If somebody's sending us an offer, let's start with candidates, I guess, because it's the easiest one. Somebody's sending us a candidate. We're going to add that to our connection. We're going to grab the candidate part of the message. We don't want to get the message type WebRTC candidate. We don't want that stuff in here because it'll blow up. It won't know what to do with that. We're just going to pull the candidate part of the message and send that to our library here. I don't think I have to say it for every single one, but if when you're receiving these messages, making sure you're looking up, if you're doing AO3, making sure you're looking up what connection is this for, like who sent this to me, and then getting it into the right connection. Same with the answer. We're going to pull the answer and add that to the appropriate connection. This is hard-coded for one connection, so it's just going to the connection. And then finally, the offer, a little bit more going on here. When we get an offer, we want to set up our connection for that specific person. So when we get this offer, we're going to add that to our connection and then create our answer, just like we created an offer when we're the one establishing the connection. Here, when we get an offer, we go, oh, crap, we got an offer, we got to do something. We're going to create our answer, which is going to have all the information about our side of the stream. And we're going to set our local description like we did when we created, this is something we did when we created the offer. When we create the accept, we still have to set our local description for this connection. And then shoot off that answer over to the server so the server can route that answer to the other side of this connection. We actually got through all that WebRTC stuff. And when it's all in action, oh my God, it kills me. I'm fixing that at some point. Oh, I did that wrong anyway. Not what I wanted to show. I'm going to show the messages. So when we click join meeting here, this is going to spoil a little bit of my my AO3, but you know what, it's whatever. So I'm going to send an offer. We see the whole thing. We can send the offer, barely. Why does it refuse to resize more? It's so frustrating. So we can see the offer. The offer has all kinds of information that we don't really care about. All of this information, which is about the eventual stream itself, like bit rates and codecs and formats and all that good stuff. We're going to send several candidates. We're going to use UDP. I got an IPv6 IP address over this port. My UFrag is these 4 characters. We have another candidate with a different IP import. Oh, we even got IPv4 on this one. Different IP import. Another different IP import. Another different IP import. So we got a lot of different options we're giving the other person. And we received an answer from the other side. This answer is going to contain the same codec and all that information being sent to us. We're going to receive candidates from the other side. We have their IP import that they want to connect on. And likewise, an IPv4. It's interesting we're getting both. That makes sense, though, I guess. At the end of the messages? Oh, yeah, that's everything we need, right? Offer, answer, and a bunch of candidates. So multiple candidates being sent in both directions, and then each peer agrees on which candidates they're going to use. They connect on those candidates, and we have a streaming connection. Any questions about all this? What are we doing next week during examples in architecture? That's a good question. I don't have an answer for you. It's one of those weeks where I have like a billion ideas that I want to do, and then I gotta, however I'm feeling that week, I pick my favorites. One of those days we're going to talk about reports. I'll go through a library and go through how to generate the report, how to look at the source code of a library, and all that stuff. I usually go through the architecture of the web server that I use as an example in lecture, but I ended up doing that a few weeks ago. So I don't know if I'll revisit that or not. And I don't know what other ones I want to choose. Also, if there's things you want to see, that might sway my opinion on what to do that week. But as of right now, since we got through the front end, all that front end stuff, I gave you everything I need to give you for homework 3. Everything's out there. So there's nothing else I have to talk about for the homework. And we have another week of homework 3 content. So I use that as a week where I can just talk about fun stuff, anything that might be interesting. So if there's something that would be particularly of interest, I might be able to fit that in next week. Any other questions? All right. Have a great weekend, everybody. I'm not going to let the music cut me off. Today's lecture question is pretty tough, too.